Video number 3 of Unit 2, Analytically Finding the Derivative of Polynomial, Polynomial Type, Sine, and Cosine Functions. Consider the function f of x equals 3. What does the graph of this function look like? If a tangent line were drawn to f of x at any value of x, what would the slope of that tangent line be? So if we were to sketch the graph of f of x equals 3, it would be a horizontal line. And we know that the slope of a horizontal line will be 0. So of the slope of any tangent line on this graph would be 0. Therefore, the slope of any tangent line drawn on a constant function is 0. So based on this thought process, if f of x equals c, where c is any constant, then f prime of x will equal 0. Right? So shown below are 6 different polynomial or polynomial type functions. I'm going to find the derivative of each function, and I want you to see if you can figure out the algorithm I'm using for each function. So for the first one, f prime of x equals 6x minus 2. For the next, f prime of x equals 15x squared plus 4x minus 3. For the next, f prime of x equals negative 9x squared plus 24x cubed. For the next one, f prime of x equals 2x to the negative 2 minus 6x to the negative 3. The next one, f prime of x equals 4x to the negative 1/3 minus 8x to the negative 3. And for the last one, f prime of x equals 3x to the negative 3/2 plus 3/2 x to the negative 1/2. So take a second and see if you can figure out what the algorithm or the rule I was using to find all 6 of those derivatives. Based on what you've seen in the table above, you should now be able to infer how to complete the following power rule of differentiation. Okay, this is one of many rules that we're going to learn for differentiation. Okay, and this is another way to notate the derivative. Okay, so this is read d dx of x to the n. Okay, so the first d It's talking about the derivative of x to the n, and then the dx is telling you what you're looking in terms of. So this is in terms of x in this case because it's dx. Okay, and another way to call this is just a differential operation. Okay, so you'll see this notation sporadically as well as the f prime of x notation. Okay, so this notation is important, and the rule, the power rule for differentiation, says that if we're looking for the derivative of some sort of polynomial or polynomial type function, we bring down the exponent, so it'll be n times x, and we subtract 1 from the exponent, so n minus 1. So you bring down the exponent and subtract 1 from the exponent. Okay, so now let's move on to the next page. In order to apply the power rule for differentiation, the equation must be written in polynomial form. So what do you think polynomial form means? Take a second to write down what you think polynomial form means. Polynomial form means that a function is in polynomial form if it is written as a sum or difference of multiple monomials. Okay, polynomial form does not include, so it is not rational or radical. Okay, so the important thing about polynomial form is that you have, if there have been rationals or radicals written, you have rewritten them so that they are in polynomial form. Okay, so we're going to do a few problems together so that you can understand what that means. Okay, so our first problem, f of x equals 2 over x squared minus 4x cubed. So we're going to rewrite the 2 over x squared in polynomial form because we do not want that to be written as a rational. So 2 over x squared can be rewritten as 2x to the negative 2. Right? The x squared being in the denominator can be rewritten as x to the negative 2. So now we have f of x equals 2x to the negative 2 minus 4x cubed. And now everything's written in polynomial form. We can use our power rule to find the derivative. So the derivative of x is equal to, bring down the exponent. So we have negative 4x and subtract 1 to the negative 3 minus, bring down the exponent, 12x subtract 1 squared. Right, and now The directions say leave your answers with no negative or rational exponents and as a single rational function when applicable. So we don't want any negative exponents, so let's rewrite this. F prime of x equals 4x, oops, nope, 4 over, negative 4 over x cubed minus 12x squared and to write this as a single rational function, that means that we need to, this is over 1, so we need to have a common denominator here, so we'll multiply it by x cubed, multiply it by x cubed, so our final answer is negative 4 minus 12x to the 5th all over x cubed. All right, so for the second problem, over here, f of x equals 3x to the 4th minus 3x squared minus 2x all over x. We can cancel out an x from every term in the numerator with the x in the denominator. So we rewrite this. We can write it as f of x is equal to 3 x cubed minus 3x minus 2. And now to find the derivative, f prime of x using the power rule, we'll get 9x squared minus 3. All right, we're going to do probably 2 more. Actually, the 2 on the left side, and I'm going to leave the 2 on the right for you to do on your own. So the 2 on the left, we have f of x equals parentheses x plus 3, parentheses x plus 2, parentheses 2x plus 1. So to solve this, we need this to be in polynomial form. So we're actually going to multiply all of these terms out so that we can get it all in polynomial form. So we get x squared plus 5x plus 6 times 2x plus 1. And when we multiply that out, we get 2x cubed plus x squared plus 10x squared plus 5x plus 12x plus 6, which we can simplify to 2x cubed plus 11x squared, 17x plus 6. And when we find the derivative of that, f prime of x is going to equal 6x squared plus 22x plus 17. All right, and the last one we're going to do together on this page is f of x equals 3x over x, the cubed root of x squared. So the cubed root of x squared can be rewritten as x over to the 2/3, and then we have 3x on top, and we can simplify this even more to just being 3x to the 1/3, because The exponent for x in the numerator can be rewritten as 3 over 3 since it's just 1. And 3 over 3 minus 2 over 3 is 1 over 3. So then f of x is equal to 3x to the 1/3. So f prime of x will be equal to, bring down the 1/3. 1/3 times 3 is just 1. X to the negative 2/3. So f prime of x equals 1 over cubed root of x squared. And since we can't have a radical in the denominator, we can rewrite this as f prime equals cubed root of x squared so cubed root of x squared all over x squared. All right, so let's move on to the next page. So in class, we learned about the sum and difference trig identities. We're going to talk about those a little bit today. So remember the two trig identities that we will use to find the derivatives of sine and cosine. So we're going to use the sum trig identities in this case. The cosine sum trig identity states that cosine of a plus b is equal to cosine a times cosine b minus sine a times sine b. Right, and the sine sum identity states that sine a plus b is equal to sine a cosine b plus cosine a sine b. So we're going to use the limit definition of a derivative to find f prime for each of the following functions. Our results will show the derivative of sine and cosine functions. So we're actually just going to do the sine function together, and you guys are going to do the cosine function on your own. By using the limit definition, we know that we're going to have the limit as h approaches 0 of sine x plus h minus sine x all over h. Now sine x plus h we can rewrite using our sum identity, and that is going to be sine x cosine h plus cosine x sine h minus sine x all over h. And if we continue, we're just going to rewrite a few things. So we have the limit h approaches 0, sine x cosine h minus sine x plus cosine x sine h all over h. So here we can factor out a sine from both terms. So we'll get the limit as h approaches 0, sine x cosine h minus 1 plus cosine x sine h all over h. Now we can separate this fraction using addition. We have the limit as h approaches 0 of sine x cosine h minus 1 over h plus cosine x sine h over h. So now here, this limit we know is equal to 0. We can bring the sine x out of our limit sign. So we'll have sine x times 0 plus, and then if we find the limit over here, we're substituting 0 in for our h's. So we have cosine x, actually, this limit here, sine h over h, we know is equal to 1. So we have cosine x times 1. So when we do this out, we get 0 plus cosine x. So f prime x equal to cosine x. So the derivative of sine is cosine x. Right, so you're going to do the work for the derivative of cosine x, and you should get that your final answer, that derivative of cosine is equal to negative sine x. All right. So now that we have our power rule and we have our derivatives of sine and cosine, we're going to move forward and use those to help us out in writing equations of tangent lines. So for each of the following functions, we want to find the equation of the tangent line to the graph of the function at the given points. So I'm going to leave the first one for you to do. Right? We want to first do the multiplication to find our function in terms of in polynomial form, then use that to find the derivative. And then you want to find your point of tangency and slope of tangency in order to write your equation. This second one, f of theta equals 4 sine theta minus theta, when theta is equal to pi over 2, we're going to do that together. All right, so in order to do that, we need to first find the derivative of all of these things. So when we have a constant up front, we can ignore the constant, and we're just going to multiply that constant by whatever the derivative is of our function. So we're going to have the derivative, so f prime of theta is going to be equal to 4 times whatever the derivative of sine is, and in this case, the derivative of sine is cosine, minus, and then the derivative of theta, in this case, our x is considered theta, so the derivative of x is just 1, right? So 1. So that's our derivative, and we'll use that to find our slope of a tangent line. Okay, so first thing we want to find is our point of tangency. So we'll put in f of pi over 2, which will be equal to 4 sine pi over 2 minus pi over 2. And we can keep going, simplify this out. So we get 4 sine of pi over 2 is 1 minus pi over 2. So our point of tangency will bring us to 4 minus pi over 2. We're just going to write that point the way that it is. So we have pi over 2, comma, 4 minus pi over 2. That's our point of tangency. So now to find our slope of tangency, we need to use our derivative function. So we have f prime of pi over 2 is equal to 4 cosine pi over 2 minus 1. So 4 cosine of pi over 2 is 0 minus 1. So our slope of tangency is negative 1. All right, so now to write our equation, ran out of space. So to write our equation, I'm just going to write it over on the side. So our y minus 4 minus pi over 2 equals negative 1 x minus pi over 2. All right. And then we'll do h of x. So our h of x is 2x over square root of x cubed when x equals 2. The first thing we want to find is our derivative. And to find our derivative, we need to rewrite this in polynomial form. So the square root of x cubed can be rewritten as x to the 3 halves okay, and when we rewrite this whole thing, so h of x would then be equal to 2x over x to the 3 halves, which we can simplify to 2x to the negative 1 half. So then h prime of x is equal to negative 1x to the negative 3 halves, which in this case is just equal to negative 1 over square root of x cubed. Okay, so I'm not actually going to rationalize this denominator because this is not our final answer. Right, so our final answer needs to be the equation of the tangent line. So because this is not my final answer, I'm not even going to rationalize it because that's just more work and it's not necessary right now. So we're going to find our point of tangency, which is when h of 2 is equal to something. So h of 2, we're going to plug in 2. We have 2 times 2 over square root of 2 cubed, which is equal to 4 over square root of 8. Which is equal to 4 square root of 8 over 8, which is just the square root of 8 over 2. So here I had to rationalize it because my point of tangency is going to be a part of my answer. So now let's find my slope of tangency. So I'm going to use my h prime now. So h prime of 2 is equal to negative 1 over square root of 2 cubed, which is negative 1 over square root of 8. which is just negative square root of 8 over 8. All right, now let me write my final equation. So we'll have y minus square root of 8 over 2 equals my slope, which is negative root 8 over 8 times x minus 2. All right, try to find the tangent equations for f of theta and g of, of f of x and g of x. We're going to move on to the last page of our packet now. Given the equation of a function, how might you determine the values at which the function has a horizontal tangent? Explain your reasoning. So in order for a function to have a horizontal tangent, that means that the slope of the tangent is equal to 0. Right? So if the slope of the tangent is equal to 0, then you either have a max or a min, because that means that f prime of x equals 0. So at what values of x will the function f of x equals x cubed plus x have a horizontal tangent? So in order to figure this out, we need to first figure out what is f prime of x. So f prime of x in this case is 3x squared plus 1. And we want f prime of x to equal 0. So we'll have 3x squared plus 1 equals 0, and we'll solve from there. So we get 3x squared equals negative 1. X squared equals negative 1/3. So x equal to positive or negative square root of negative 1/3. Now we know that taking the square root of a negative number gives you an imaginary value. So since f prime of x doesn't equal 0, because we would get an imaginary number, then f of x has no horizontal tangent. Right? Now let's look at a trig problem that's similar. So at what values of theta, at which the function f of theta equals theta plus sine theta, has a horizontal tangent on the interval 0 to 2 pi? So again, we need to figure out what our derivative is. So f prime of theta is going to be equal to, derivative of theta is 1 plus the derivative of sine, which is cosine theta. And we want f prime of theta to equal 0 for a horizontal tangent. So 1 plus cosine theta equals 0. And now we're just going to solve. So we have cosine theta equals negative 1. And on the unit circle, the only time cosine equals negative 1 is if theta equals pi. So at theta equals pi, you have a horizontal asymptote on that interval. All right, that's the end of this video. If you have any questions, ask them in class tomorrow.